Most people have seen a satellite image before. Maybe it appeared in a weather report. A storm turning slowly over the ocean. A line of clouds crossing a continent. A wildfire map. A flood map. A view of Earth from above, clean and distant, as if the planet has become something easy to read. At first, it feels simple. A satellite is in space. It looks down. It takes a picture. And from that picture, people understand what is happening on Earth. But that simple idea is only the surface. Because a satellite image is not always just a photograph. And a satellite does not truly know what is happening the way a person knows something. What it does is more careful than that. It measures. It records signals from Earth. It observes the same places again and again. It sends down information that must be processed, compared, and interpreted. Only after that does the image, the map, or the warning begin to mean something. So the better question is not only, what can satellites see? The better question is, how do satellites turn signals from Earth into useful knowledge about what is happening on the planet? That question begins with a familiar image. A satellite view can look like a picture from above. But behind that image is a larger act of observation. This is the basic idea of remote sensing, gathering information from a distance. From space, a satellite may be far away from the forest, the ocean, the storm, the city, or the field it is observing. But distance does not mean blindness. Earth is constantly interacting with light, heat, atmosphere, water, land, clouds, and surface materials. Some energy is reflected. Some energy is emitted. Some signals can be sent from an instrument and measured when they return. A satellite can be designed to detect those signals. That is why thinking of a satellite only as a camera can be misleading. A camera is one kind of instrument. But many Earth-observing satellites are not simply taking ordinary pictures. They are measuring what comes from Earth. Some instruments are passive. They detect energy that is already there, such as sunlight reflected from land or clouds, or heat emitted from the surface. Other instruments are active. They send out their own signal, then measure what comes back. This difference matters because Earth does not reveal itself in only one way. A green forest, a dry field, a warm city surface, a cloud system, and a flooded area may all send back different kinds of information. To the human eye, a place may look ordinary. To the right satellite sensor, that same place may show heat, moisture, vegetation condition, surface roughness, or cloud movement. The satellite is not guessing. It is measuring a signal. But one signal is not the whole planet. That is why different sensors create different versions of Earth. One sensor may show a natural color image, something close to what the eye might expect. Another may help reveal vegetation patterns. Another may show heat. Another may use radar to read the surface in a different way. The same location can become several different kinds of information, depending on the question being asked. If the question is, where are the clouds moving? One kind of observation is useful. If the question is, where is the land surface unusually warm? Another kind may be needed. If the question is, has vegetation changed? A different signal may matter. If the question is, can we observe the surface even when normal optical imagery is blocked? Radar may become important. This does not mean every satellite can do everything. It means satellites are built with different instruments for different tasks. A satellite looking at weather is not the same as one designed to study land change. A radar satellite is not the same as an optical one. A multispectral image is not the same as a normal photograph. Each sensor is like a different way of asking Earth a question. And once we understand that, a satellite image starts to feel less like a simple picture and more like a reading. But even a reading from space is still only a moment. A single image can show what a place looked like at one time. That can be useful. But many of the most important things on Earth are not understood from one moment. They are understood through change. A forest is not only a forest. It may be growing, burning, recovering, drying, or being cleared. A city is not only a city. It may be expanding, heating, brightening, or changing its land use. A river is not only a river. It may be rising after heavy rain, spreading into floodwater, or shrinking in a dry season. From the ground, these changes can be difficult to see all at once. From above, repeated observation makes another kind of understanding possible. A satellite can return to the same region again. Another satellite may observe it too. Over time, images and measurements can be compared. Then the question changes. It is no longer only, what does this place look like? It becomes, what is different from last week? What changed from last season? What pattern is forming over the years? This is why long-running satellite records are so valuable. They help people notice change that is too large, too slow, too remote, or too widespread to understand from one point on the ground. A single satellite image is a snapshot. Repeated observation can become a story. But even then, the story is not finished the moment the data reaches Earth. What comes down from a satellite is not always a clean map ready for a viewer. There can be raw measurements. There can be corrections. There can be processing steps. There can be comparison with other data. There can be interpretation by models, systems, and human experts. This is one of the easiest parts to miss. The clean image shown in a report is often the polished end of a chain. Before it becomes a map, the data may need to be organized, calibrated, cleaned, corrected, classified, or combined with other information. Clouds may need to be accounted for. The angle of observation may matter. The type of sensor may matter. The purpose of the product may matter. A flood map, for example, is not just a beautiful satellite picture. It is information shaped for use. A fire detection layer is not simply the satellite saw fire. It may be based on thermal signals that need interpretation. A land change map is not only a before and after image. It is a comparison that must be handled carefully. That does not make satellite data weak. It makes it more understandable. The useful product is not magic. It is measurement turned into information. And information becomes most important when it helps people decide what to do. This is where satellite observation connects back to life on the ground. Weather services use satellite data as part of wider forecasting and monitoring systems. Emergency teams may use satellite and geospatial information to understand floods, fires, storms, or damaged areas. Farmers, planners, researchers, and public agencies may use satellite information to monitor land, crops, water, cities, or environmental change. The satellite does not make the decision for them. It supports the decision. It gives a view that may be too wide, too remote, or too fast-changing for people to gather from the ground alone. A person checking a weather forecast may never think about the satellite instruments behind it. A community looking at a flood warning may never see the raw data. A farmer or researcher may not think of the orbit above Earth when looking at a map of vegetation conditions. But the chain is there. Signal, sensor, measurement, processing, interpretation, decision support. That is how something far above Earth becomes useful to people standing on it. And because people depend on this information, it is just as important to understand what satellites cannot do. Satellites are powerful, but they are not all-seeing. What they reveal depends on the sensor. It depends on timing. It depends on resolution. It depends on weather conditions. It depends on processing. It depends on interpretation. An optical satellite may be limited by clouds. A radar instrument may be useful in different conditions, but that does not mean every satellite has radar. Some data may be available quickly. Some data may take longer. Some changes are easy to detect. Others require careful analysis. This is not a reason to dismiss satellite data. It is a reason to understand it properly. A satellite image is evidence, but it still needs context. A map can be useful, but it is not automatically the whole truth. A warning can be supported by satellite data, but it usually belongs to a wider system of models, agencies, experts, and ground information. The more clearly we understand the limits, the more useful the information becomes. Because the real value of satellites is not that they see everything. It is that they give humans another way to notice what is happening. At the beginning, a satellite image may have looked like a simple picture from above. By now, that same image should feel different. Behind it may be reflected light, emitted heat, radar returns, repeated observations, raw measurements, processed maps, human interpretation, public decisions. The image is only the visible surface. The deeper story is the chain behind it. Satellites do not replace the need to understand Earth from the ground, but they add a view that the ground alone cannot provide. They help turn a changing planet into information people can study, compare, and use. And that is how something moving far above Earth can help us understand what is happening down here.